Hello, class. Good morning, good afternoon, good evening. It depends on from where you are joining the program. Welcome to week number 7, session number 2. Yesterday, we talked about the introduction to machine learning, how we are trying to mimic the human behaviors in making decisions using systems, using algorithms. And today we are going to learn the first algorithm, and that is decision tree. So a few things that we need to prepare the data for or to apply an algorithm to our data to try to approximate the reality. Okay, so number one, we need to identify the inputs and the target variable. We need to tell this algorithm, hey, these are these features are the inputs, and this feature is a target variable. In other words, we need to identify x's and y. X is capital because we might have more than one x, and y we are going to have only one target variable. So looking into our data, so this is our data here. So let's assume this is all our data. Let's assume this is all our data, and let's assume this is 6 million records. Okay, so in this data here, we have a target variable, and the target variable is the element of the data that we are trying to analyze and understand. So we are trying to understand if any of our clients will purchase the term deposit or will get subscribed for the term deposit. And if yes, of course, we are going to make a decision to, figure out how to handle or how to deal with the customers or clients interested in the term deposit. Maybe reduce their, reduce their premium, do something for them in general. So anything else, it's not. It's simply inputs. So to determine if a client will be a 0, or I know we have someone 1. Of course, we need every other features. We need all the features, but we don't know yet. We don't know yet how much we need. So we are going to need a number of employed, durations, confidence index, month, May, etc. So we are going to need all of these features. And these features, they are called input. They have many names. They are called input. They are called inputs. They are also called features. They are also called predictors. They are also called independent variables, and they are also called descriptive uh, descript, descriptive features. They have many names, and just to make it easy, we call them X X's. Make it easy for the algorithm. We are going to call them X's. Okay. For the target variable, it's called. It has also many names. It's called the target variable. It's also called output. Sometimes it's called outcome. Sometimes it's called dependent variable. Sometimes it's called label. Sometimes it's called class. And to make it easy for the model, we are going to call it a Y. Just call it a Y. Okay. Any question, concern? Any doubt? Anything that's not clear? Please speak up. I want to see a dialogue here. Please speak up. Anything clear, not clear, any doubt, any concerns that you guys want me to clear out before we proceed?
Well, just really fast. I know we had spoken about scaling the data. If the data has a lot of, it's quite different. Like the age in this example is 56, whereas the other
Right.
independent variables are zeros and ones. Is that a concern at the moment, or?
Yes, we are going to scale it once we we are going to scale it.
Oh, okay, thanks.
There we go. Okay, so that is the first thing we gotta do is we need to tell the system, hey, this is all our x's and this is our target variable. Number two, we need to split the data or partition the data. Yeah, we need to partition. Yeah, we need to partition the data into at least two parts using the 80% 20%, 80% versus 20%. And the 80% is called training set, and the 20% is called testing set. So we are going to try to apply the algorithm on the 80% to learn a pattern, to learn something, and we are going to test. We are going to test the model or the performance of the model on 20%. So this is a random. This is random split. Random. Okay. So let's assume this is our random split. Okay, we are going to split. So we are going to have here two partitions. Okay. So we are going to split. So we got the 80%. And we are going to have 20%. And 20% is called training set. and 20% is called testing set. Okay, and number 3, we are going to train the model on the 80% using a method, a model method, using a model method called fit. It's a function. Okay, and in this fit we need to pass into it all x's and the target variable, and all x's and y. Number 4, of course we are going to learn something, we are going to learn something from this exercise, from the fit, and whatever we learn we are going to test the learning on the 20% using a model method called predict. And in predict we are going to give it only, we are going to give only all x's of the 20%. So we are going to hide the 20%. And what this prediction is going to do is going to create sorry guys, is going to create a new feature called predicted target variable. And number 6, we are going to compare the predicted target variable to the actual target variable to see the performance of the model. Okay, that is the plan. Very easy. So number 1, we are going to identify x and y. Number 2, we are going to partition. Number 3, we are going to train the model on using the fit. We are going to train the model using the fit function on 80%. Then we are going to test the learning, whatever we learned on the 20%. So when we train the model, we are going to give it x's and the y. So both will be given to the fit function. When we test, we are going to give using the predict function, we are going to give only x's. And this predict function, what it does, it is going to create a new a new column, and this new column is called predicted target variable. It's going to create, it's called y hat. Y hat. So it's going to be zeros, 1, 0, 0, 0, 1, 0, 0, 0. And now we are going to compare the predicted target variable to the actual target. This is the y. Compare the y hat with the y and see how different, how closer the y hat is to the y. That is how we are gonna learn how great the model is. Okay, questions, concerns? John, please.
Sorry, hi brother. In case of no like unsupervised, sorry, in case of unsupervised, so if we do not have a target variable, so how we compare the result then?
Yeah, that is it's a different scenario. It's called so. And if we don't have a target variable, that is called clustering, or it's called unsupervised learning. And with unsupervised learning, there are other list of algorithms we are going to try. We could try A/B testing, association rules, clustering analysis. It's a whole different direction. We are not going to
Okay.
compare. We are not going to compare. We are going to learn the error. We are going to learn how closer. We are going to learn the errors. Using the, let's say that if you were to use a clustering analysis, which simply it does use Euclidean distance. So we need to compare the intra distance with enter distance. It's a different direction.
The steps would be different too, right?
Yeah, steps we don't split. Yeah. Steps are different. Yes, we don't identify x and y because we don't have y. We don't split because we are going to use the entire data set. Yes, steps
Okay.
are different.
One
Mhm.
more
Oh,
question
okay,
is that
thank
for,
you. Mhm.
for the feet
Yeah,
function,
Mir, Mr. Mir, please speak a little bit louder.
the feet function that you have, is it always the case for the supervised learning, or is
It's
it
always the case. Always is a fit is a part of the algorithm.
okay for
Fit
supervised
and
learning
predict.
when we know the target variable?
Yes, supervised learning. Remember, we have two type of supervised learning. A supervised learning where the target variable is a binary nominal multi-class that is called classification, and supervised learning where the target variable has a continuous value that is called regression. Both of them they follow under the same umbrella.
Thank you.
You're welcome. Other questions, concerns, please? Okay, so let's do that. We are gonna first read the data and partition and wait, and then we are can come back to explain the concept one more time. I should have shared the code with you guys. Unfortunately, I totally forgot. So I'm gonna share the code later. But anyway, so this is what we have from the previous session. We read version number 2. So we read version number 2, then we pre-process the data by looking into missing values, by looking into outliers. That's what we did. Then we learned how to transform the skewness. Excuse me. Then we learned how you know how to select features using one method that is called feature importance. So this is all what we did in the previous session. So it's a different type of skewness. Okay, and finally, we save the data in under the name bank application version number 3. So now we are gonna read. So now we are going to read the data. So now we are going to do machine learning. As usual, we are going to import. Some packages that we are going to need. And the most common packages is NumPy for numerical Python, Matplotlib for data visualization, Pandas for data analysis, analytics, and manipulation. Okay, then we are going to import version number 3. I don't think it's going to work because probably the data is not in the same location. Let's run it. Actually it did. Okay, so here we go. So we got all our data, and then we got one animal that been saved. So we should, I believe, we should set. I think it's call names name equal false. I think this is a. I have to figure out, but yeah, it's a method that if you set it up, it is not going to create. It's not going to create an index. But now, since we have index, we are going to drop it. And let's take a look into the shape. So we got 41,188, and we got 51 features. So you tell me, out of these features, can you tell me out of these features how many x's we have and how many y's we have? Can you tell? We already know
Yeah.
that.
41,188 x's.
I mean,
No, 51 x's and 41,188 y's.
no.
I think there is only one Y and 50.
Okay, Asma Khalid, what did you say? I barely hear you. Asma Khalid.
It's 1 Y and 50X.
Yes, sir. We are going to have 1 y and 50 x's. Look into the data again. So we got 1, 2, 3, 4, 5, 6, 7, all the way to the end. That is 50. And we got 1 y. So the 41,000, that's the records. This is the records. The 51 is the columns, and in these columns we have 50 of them, they are x's, and one of them is a target variable. I mean, is it clear? I mean,
Yes, thank you.
yeah, welcome. And let's take a look into the target variable. So for target variable, we have for target variable, how many levels we have for target variable. So target variable, what type of target variable, what type of the data that we have for target variable? Can you tell me?
Binary, yes and no, right?
Yes, sir.
0 and 1.
Binary, no. Yes, no is not binary. Yes, no is nominal. Binary is 0 and 1.
Right. That's what we have.
It's a binary. So we get how many levels? Binary is 2. 1 and 2. So we got a 0 and 1. So this is what we have in the target variable. And how many zeros that we have? We got 89% is a 0, and let's say 11% is a 1. So if you were to guess, let's say that we got 41,000. We got 41,000. I believe 41,100. Let me see. 188. So this is the historical data. Agree? Yes, no? Any objection? This is our historical data.
Yes.
let's say that we have 2 more clients. I'm going to pick names from the list. We got Jamal, and let's say we got Amir. There are 2 new clients. They just joined yesterday. And if we were to guess if they are going to have a term deposit, what would be our guess using the historical data?
89% they're gonna say no, and 11% they'll say yes.
Yes, sir. Thank you, sir. 89%. Jamal will say Jamal and Mir, they are going to say yes. They are going to say no. 11%. They are going to say you got it otherwise. 11% they are going to say yes. If we were to guess without using machine learning. So this guessing here is called the dummy model. So our dummy model is telling us that any new client will have a probability, 89% probability they will not purchase, they will not get the term deposit, and 11% that will get the term deposit. So we want to build a model that beats this percentage in here. No, if you were to create a model with with probability, say 90%, is this a good or a bad?
Very good.
Why?
Because your I guess data is showing 89%, so you're saying you're able to predict it at a much higher probability.
How much higher do we have?
If 90 was the prediction for...
No, my question is how much higher do we have compared to the dummy model? It's only one level.
1%, yeah. Mm-hmm.
So how much they are going to cost me if I were to hire you as data scientist? At least 120,000 per annum, right? Do you think if I were to invest in you 120,000 per annum to give me one level, is that good or bad? I would rather save my 120,000 and stay with my 89% rather than hiring you for 120,000 and give me one level more prediction than the dummy variable. So in theory this is good, but in practice this is very bad. So we want a model, at least a model that beats the dummy model by at least 3+ levels. If we were to get 93, I think this is better. 90, I don't think it's a good prediction compared to what that you are gonna cost me. Okay, so we got 80%. So we got 89% and of zeros and 11% of ones. So again, we are gonna identify X and Y. So we are gonna identify X and Y. X is everything except all features except term deposit. Why? Can anyone tell me why we are excluding the term deposit?
Because that's our predicted.
Is input.
Not the input. You are still confusing the confusing terminologies. The term deposit is our target variable. It's simply we are telling X is all features, all inputs except the target variable. That is exactly what we're doing here. All features.
Sorry, I was saying same. I was saying X is input, so we should not have output.
Just be careful. Be careful. In the interview, the moment you miss up something, they know you are a fake data scientist. You have to be careful with the terminology you are using. Okay. So, but you got it. It's simply you confuse the words. So we need to identify all X's and the target variable. And in our case in here, we got, give me all features and drop the column. X is equal 1 is a column, X is equal 0 is the row. So rows is the records. But since we are using we need the column, X is, it comes with the drop function. So the drop is a function. So for X's, give me all features of the bank applications, but please go ahead and drop the column of the term deposit because that is not an input. For the Y, is the bank dot the target variable. Okay. Any question, concerns about these two pieces of code, two lines of code? Okay.
One question more.
Yes, sir.
In a drop function, if on the X in the row we don't have a name, so we just give the index.
Yeah, so you could give an index, you could give an index. Yeah, that works. But the drop is done on the column names.
Okay.
Okay, there are other methods that we can use to eliminate a record.
Okay.
Okay, so we got 50. We got 41,188 and 51 columns. So now we are going to drop. So we just created two variables. We created X. So if I were to do X shape, what do you guys expect? So now we created another variable, which is simply all the features excluding the target variable. So what do you expect with the shape?
We'd still expect 41,188 records with 50 columns.
Yes, sir. Let's take a look. Here we go. 41,188 and 50 columns. How about the Y?
That'll be the same number of records, but just one.
Yes, it's going to be it's going to be one. It's going to be it's 41,188 records and the one. And after we identify X and Y, the second step in the process is the split. So we are going to split in 80% and 20%. And when we split, so this is our 41,188. So this is our 41,188. Okay, and randomly we are going to split into 80% and 20%. And this 80%, it will have its X and its Y, and this 20% will have its X also and the Y. So for this 80%, we are going to give it a name. It's called training set. It's a set that will be used that we are going to use to train a model, to train an algorithm, and this 20% is called testing set. So X, we are going to give it a name. It's going to be called X underscore training set, and the Y is going to be called Y underscore training set, and here we are going to call this X underscore testing set, and the Y will give it a name, Y underscore testing set. So we are going to get X's of 80% and Y of 80%, X's of 20%, and Y of 20%. Okay, so now we are gonna, from scikit-learn. Scikit-learn is a huge Python library. Scikit-learn, it's a huge package library. I'm gonna share this with you guys in the chat, just if you guys wants to take a look into this later. So this scikit-learn is a machine learning library that it's used for classification. Any classification algorithms can be used for. It's also used, classification is a supervised learning when you have a target variable that is a binary or a nominal or multi-class or trinary. Regression is a supervised learning algorithm. Supervised learning where the target variable is not a binary, is not nominal, is not trinary or multi-class, it's a continuous. A clustering is unsupervised learning where we don't have a target variable. The scikit-learn also can be used for dimensionality reduction. If you want to reduce the dimensionality of your data, we can use it. It's also used for model selection. If you want to build many models with one click and compare them. And it's also used for pre-processing. If you want to eliminate, let's say, if you want to handle missing values, outliers, if you were to transform categorical into numeric, the scikit-learn can do it. It's a huge library. So we are going to import. We cannot import. For the beginning, we imported NumPy as NP. Why we did not import scikit-learn? Why we did not import the scikit-learn, the entire library? Import scikit-learn as SKL. Let's say that. Why we did not do this?
Because it's a large library and takes up space.
Yes, I mean it's a huge. Yeah, it's. I mean, you are going to import everything from the cloud. Of course, it's going to take forever to load, and it's going to consume a lot of memory. It's going to consume a lot of resources. So what we have to do instead is importing what we want. We are going to import what exactly need and play around it. So we are going to import from the scikit-learn model selection. We are going to import from the scikit-learn model selection. We are going to import from this subcategory of the scikit-learn. And we are going to import what? We are going to import model selection. We are going to import the model selection, and we are going to import splitting is somewhere in here. So we are going to import the train test split. So this is the method we are going to use to train, to split the data. And we are going to split the data into training features or training X and test X. Yeah, training X. You give it whatever name we want. In our case, we are calling this training features, and this one training target, and this one test feature, and this one is test target. So whatever name you want, it doesn't really matter, but just choose a name that wouldn't confuse you later. So we are gonna test we are going to split into two. The first one will have two features, training features and the target variable. The second one will be testing features and target variable. And we are going to use the method training test split, which is a function. Anything with parentheses in Python is a function. And of course, a function has parameters. So we are going to split. We are going to use the method that we imported, and we are going to there we go. Let me make another screen. So it's a function, as I said. So we are going to use the method that we imported from scikit-learn, and we are going to split the data. We are going to split our x and the y using 20%. This size we are going to be using 20%. So it means 80%. We are going to have two partitions, 0.8 and 0.2. And we are going to specify the random state. A random state is simply guarantees reproduce the same split if you were to run it twice. So we are going to split into 80% and 20%. So 80% we are going to have x's, comma y, and the x's will be called training features, and the y will be called training target. And for the 20%, so this is 80%. 20%, we are going to have x again and comma y. So x is called test feature and y is called test target. So any question, concern about the splitting?
Mo, I have a question about the random stage.
Sure.
Yeah.
So the random state, if you did not specify the random state, okay, and let's say that this is our 41,188, and you randomly, it's random. Please forget now. Remember the word. It's a random split. Okay, I mean, at this point of time. So let's assume this is you. Okay, and when we split the first time, when we run this the first time, you are gonna go because it's random. Let's say that you run it, then you are gonna go with 20%. Yeah, you are gonna be in the 20% randomly. Okay. And if we did not specify the random state and give you a number, any number, it could be a random state 1, 2, 3, random state and 50,000, and it doesn't matter the number. This is number in here. So if you run it again, run the code again, there is no guarantee that the same 80% is going to be always the same 80%, and 20% is going to be always 20%. So we are going to get, because we are doing it random, of course, we are going to have 80% but different features than the first time. And if you keep having different features every time you run it, of course, you are going to confuse the model. So to avoid having different random features every time we run this, we need to specify a random state equal a number. And if I give you the same data set, I mean, please go ahead and mute yourself. I mean, please mute yourself. Thank you, sir. So if I give you the same data set and the same code, and I asked you to run it, and your random state is 45 and my random state is 45, then when you run this code, your 80% is going to be identical to my 80%. Your 20% will be identical to my 20%. If you specify a random state and you change the value for 45 to, for example, 450 or 12, or then you are going to get 80%, 20%, but your 80% is going to be different than my 80%, and your 20% will be different than my 20%. And when we run the model, we are going to get two different accuracies. I mean, is it clear? That is why we need sometimes we need to set random state to a value.
Okay, so random state basically is just preserving the selection that we've selected.
No, the random state guarantees the reproduction. The same values that goes to 80% and the same values. So if you run it twice if you run this example twice without setting the random state, you could be the second time it could be in the 80%.
Got it.
Okay.
There is a parameter called stratify.
Brother Mo, if it is a
Yes, Akhtar.
Yeah, if it is the same value by using random state, so why we need to run twice? If is the 2080 will be the same in terms of the values.
Yeah. So because as data scientists, you have to try many times before you determine if a model is good or bad.
Yeah, but the question is if it is the same value. We are before talking like because maybe 0 and 1 like all 0 maybe go to 80%, so we have to try more, so it should like change the distribution. But if the random state define it is the same value, so there is some confusion here. So how we can then?
When you are, I get your point. When we set the random state, we guarantee that the model, because in the model, so this is the model we are going to use. So and the model, we are going to have some parameters that we need to change. So we want to make sure that we test the parameters and the same split. If you test the parameters and every time you change the split, of course, we are not going to make sure that if we are learning something out of using the parameters. So, for example, if you were to choose a parameter that is, max depth is 4. This is a parameter for decision tree, and we'll talk about this shortly. And you got, for example, you build a model, and the parameters that you choose, you got 4, and you get 88%, and you said, probably let's try 5. So I want to try 5 and the same split, 100%. I don't 100% the same data if I were to see if 5 is better than 4. If you change it, if you try 40%, 4 on a different 80% and 20%, and 5 different 80%, 20%, whatever the accuracy you are going to get, it's not accurate. So if we were to test a parameter of a model, we have to test it on the same 80% and 20%. That's why setting up the seed helps to make sure that we are testing our parameters and the same exact 80% and 20%.
Mm-hmm. So to change the value, we should change the random state, and to change the within the parameter within that. So we should keep.
Once you set the random state, just keep it as is. We don't change this. This is what it does. Random state equal 45. So it tells the model, okay, go ahead, try 4 on me, and I promise I'm gonna keep the same records that you tested the 4 on any future number that you want to change. You want to try 3. Okay, the model is going to try the 3 and the same records that we trained for, we tested for. Then we are going to keep it for 5, etc. So that in this case, in this scenario here, we guarantee the fair comparison between 3 and 4 and 5 and 6, because we are trying them on the same exact records. Okay, let's give you a very good example. Let's say that we have a machine. No, a machine, just a machine, and we got, and this machine here has, let's say that has some heats. Okay, and we got some raw materials. We got some raw materials. Let's say we got red raw materials and made of fabric. Now blue raw materials is made from something as silicone or something. And let's say that this machine has some parameters. Let's say it had heat, and this heat it could be 1, it could be 3, 2, it could be 3, it could be 4, etc. So we want to see which number is better. So if you try the heat equal 1 on a red, then next so your job is to determine which value is better. And now we are going to do machine. Again, we are going to compare 1 to 2. Heat equal 2. But you try the on blue. Do you think you have a fair comparison on 1 and 2? Yes or no?
No.
Why?
No. Because now the data set that have red and blue, that have changed with respect to the comparison, so it may have different.
To make a fair comparison, what do you think we should do?
We should keep same red with respect to these two iteration.
Yeah, to keep the same red raw materials, is we are going to do here we are going to apply this random state. Simply we are going to do here comma random state and give it a value 45, comma random state 45. That is why this is what the job of the random state is, to make it a fair comparison with all parameters of your model. Okay?
Yeah, that we understand, brother. My question was this: okay, once time you define the random state, so after that your value and the 80% will be the constant for these sub-function of machine 1, 2, 3, 4, right?
Right.
But might be in this case all is your 0 in the random state, in the 80%.
Yeah.
So to change the ratio between 0, 1, you have to go back to random state again to change for maybe the other iteration.
Yes, you could do that, but how do you determine if you got zeros in one area and ones? So number one, we are splitting on 20% 80%, right?
Mm-hmm.
And how many zeros that we have? How many zeros that we have, and how many ones that we have?
I think we have 88 and 11. Yeah.
There is no way. There is no way you are gonna get 100 all the zeros in one side and all the ones in one side.
Mm-hmm. Yeah, from this data we do not.
Yes,
but consider we have 80 and 20.
If we have 80% and 20%, there is a chance, there is a risk that you are going to get all zeros in one side and all ones in one side. Okay, but let's assume that it's 80% and 20%. And of course, when we split, there is a chance that all the zeros will go to 20%, and other ones will go to 80%. So we are going to run it. And how do we fix it? So it's simply we are going to compare the accuracy. At the end, we are going to compare the accuracy, and it's called confusion matrix. So the confusion matrix will definitely tell you if the model is having some problems. I'm sorry, if the data is having some problems. So you have a great question, data scientist question, but it doesn't. It's very rare to happen. Okay.
Thank you, got it. Yeah, thank you. I got it now.
Thank you for the great question. Okay, so we identified X and Y, and now we are going to split. Okay, so I'm going to test your understanding. Since we split, if you were to look into the shape of the training, so we could look into the shape of training set, testing set. What do you think? What would be the value?
The training features would probably have like 32,950 records. That'd be 80%.
Yes, sir. 32,900. So where this 32,950 comes into the play? Where do we get this? I want someone else. Someone else, please. Mayor and
80% of the sample. That's a train up.
Mayor, please shut up. Yeah, I know you know, sir. You know, someone else. Where this?
It's 80% of the original set.
Yes, it's 80%. I want to make sure that everybody in the same page. So it's 80% of the 41,188. And if we were to do the shape, and we got 50, where is the one? Where is the other one? Actually, we got 51. Where is the one? The one is the target variable. Is the target variable. If we were to do the shape, we are going to get 32,950 and 1 per. There we go. And if we were to do the shape for the test, we are going to get the remaining
20%.
It's going to be 8,283. I'm sorry, 38, which is a 20% of the 41,188. And for the shape of its target variable, we are going to get 8,238 and 1. Okay, so that is identifying X and Y and splitting.
Mo, I have a question. You can go back to the function, please.
Yes, sir.
It does not print the in the training target the test dot the training target. It's not printing the column. Column 1. Yeah, it's 8 to 3.
Yeah, it's a so.
Is it like understood? Like
yes, it is. Yes.
Okay.
Yes, but anyway, it's a 1 in there. It's a 1 because we start with index 0. That's why you don't see it. It's index 0. So in Python, this is index 0, index 1, and 2, and 3, and 4. So when you have only one feature, it has index 0. Good. So the split. So now we split. Now we split into 80%, 20%. So we got we identify 20%, 80%, and now we need to train a model. So we just did the first 2 parts. So before we do the model, we need to. So this is the model. We need to compare the model to something that we already know. So we need to compare the model to what? So we have to have something to compare our any model we are going to build. What are we trying to compare the model to? So let's say that if Amin is a new client, he just joined us, what would be the probability if we were to guess his decision to make a term deposit? What would be the probability?
It is based on the model what we design output. It will give us like this type of record.
No, we already have this in the historical data.
So according to the dummy test or the dummy data, it'd be like 89% would be.
Yes, sir. So this is what we have so far. So if Amin is a new client, he's just joined us. If we were to guess his value in his decision is going to be 88%. Okay, 88%. So we want to build a model and compare it to the 88%, and this is called the dummy model. Okay, so let's build the dummy model first. And the dummy model we are going to import from so take a look into the it's term deposit. So let's take a look into the percentage of the target variable one more time for the historical data. So we get 88%, it's a 0, and 11% is a 1. So from the scikit-learn again, the dummy, we are going to import the dummy classifier. The dummy classifier is going to make the guess using the actual percentage that you have in your historical data. So we are going to create a variable, an object. It's called dummy baseline. It's called model baseline or a dummy model. And yeah, let me explain the code piece by piece. So we are going to import the method. This is called the method dummy classifier from the scikit-learn. We are going to create an object. You give it whatever name you want, and of course we are going to use the dummy classifier method and some parameters. So random state, you could set it to none, you could set it to 45, you could set it to whatever, constant none. Anyway, we don't need this, but we want to classify, we want to learn the classification using the most frequent. What is the most frequent in our data set, and the target variable of our data set? So we have a target variable, and you have two values in it. We got the zeros and the ones. What is the most frequent?
0.
So
0.
we are telling this. Please go ahead and only learn from the zeros. So what would be? So we build a classifier on the most frequent, and now we are going to fit the classifier on our 80%. 80% X, 80% Y. What do you think would be the output? What would be the accuracy of this model? I mean, what would be the output? What is the probability of zeros?
88%.
And 1 is going to be, so the output is going to be 88%. There we go. And so we build the model using the fit function. So we initiated the engine for the model, and we used the model that we initiated, and we fit means we trained that model on the 80%, and now we are gonna hit on the 20%. So we got all the zeros, and now we want to calculate the score, and it's 88.6. So any model that we are going to build down the road has to be this value. I mean, please go ahead and mute yourself unless you have a question or concern. Thank you, sir. So the dummy variable is simply, trying to predict all the zeros, trying to predict the most frequent of the target variable, and the most frequent is the zeros. So it's 88.6, or it's 88.6, almost 0.7. Okay, so now this is what we just did. We identified x and y, then we partition, and we already have a model that is a dummy model that is 88%. Now we need to build a model, and the first model we are going to do is called decision tree. So how this decision tree works is every model, all the classification model will go through the same process. You identify x and y, you split the data into 80% and 20%. You learn about, this is number 4, you learn about the model, the dummy model. Then you train the model, you test the model, then you compare the accuracies of the model. But and models, they have different behavior. In classification, and this is something that we are going to learn from the 30-week program. So we got supervised learning, and supervised learning, if you have a target variable that is a binary or a nominal or categorical, we'll do classification. If the target variable is a value, we are going to do regression. And under classification, of course, we got many algorithms: decision tree, naive Bayes, logistic regression, support vector machine, kernelized support vector machine, a k-nearest neighbor, INN, etc. There are so many models, and all these models, they use the same scenario, the same process. You need to identify x and y. You need to split into 80%, 20%. Then you need to train the model on 80% using the fit function. You need to test the model on 20% using predict function. Then you need to compare the accuracy of the model to determine if the model is good or bad. But the decision tree behaves totally different than naive Bayes, which behaves different than logistic regression. So every model that you see here, even though they follow the same rules, the same list of the same workflow, the way they treat, the way they handle the data inside is totally different. And today we are going to talk about decision tree. Of course, we are not going to cover everything. This is a part of the 30-week program. Probably we are going to cover decision tree and any other models, and we'll be done with this 10-week program. So as I said, even though they follow the same process: identify, partition, then train, test, and compare, they behave totally different. Okay, coming back to the question of the brother who asked, why do we need to do a dummy? So number one, the dummy. So if you were to compare yourself to, if you were to compare yourself, we have to have something to compare it to. You want to compare how smart you are compared to me, or how much knowledge that you have compared to me, or how fast you are compared to me. So you have to compare yourself to something else. and that's something for the model. For the model, we have to compare it to something else, and the something else in our case is the guessing. So if we were to guess you as a new client who just joined us, of course we are going to guess you based on what we already know from the data, from the historical data. We already know in the historical data that 88% of our entire client list, they have a 0, and 11% they have a 1. So let's say that you are a new client who just joined who just purchased, who just created an account with the bank, and we were to guess. I'm going to guess as either 0 or 1. So let's say I want to guess you as a 0. Now, what is the probability you are going to have a 0? Of course, I'm going to go with the probability of the historical data, that is 88. So we are guessing you using the most frequent value of our target variable, and in our target variable we got the zeros and ones. That is the word the frequency comes into play.
Mo,
Yeah,
but
please,
that will.
please hold on. Let's make sure the brother who asked the question is clear.
Yes, thank you.
Fahad Ali, is it clear?
Yes, thank you.
Amin?
Yeah, so that result, basically, it will be applicable to any new joinee. So any new joinee, like we will assume him to fall to the 88%.
Yes, but we want better than that. We don't want to guess. Okay, so we hired you as my data scientist because I don't want to guess anymore. I want you to come to have a better solution than guessing. Okay, that is where the machine learnings come into the play. So we want machine learning to take data here and learn a pattern that would determine a better value of the target variable. So if I were to guess, I don't need. So I want to hire you. I'm going to invest a lot of money in you so that you give me a better guessing, a better solution that is better than guessing.
Got it. Okay.
Okay, I mean, mute yourself, please, because there is an echo. When you are on, there's an echo from your side. So every new journeys, of course, we are going to get the same guessing, 88, 88, 88. But it's not doing anything to the business because everybody can guess using the historical data. So we want a model, and this model, of course, to make sure to determine if the model is doing better, we are going to compare it to the 88%. So we have to have a model that beats 88%. At least this model that we are going to learn today, if we have time, it has to have an accuracy higher than 88, 90, 91, 92, etc. Okay, and the first model we are going to use is called decision tree. And of course, I have a presentation, which I don't think I will have time to go through. So I will simply try to explain it as much as possible. Okay, so let me make another screen of paint. And let's say that we have, this is our data again. I'm trying now to explain the first model. So this is our data. Let's assume this is all our data. Okay. Yeah, let's assume this is all our data. Let's assume this is 6 million records. Okay, so we got 6 million records here. And of course, we are going to split. We need to split randomly. Excuse me. Okay. And now we are going to use decision tree. Decision tree. Yeah. Decision tree is an upside down tree. It simply uses rules. Rules. Yeah, it uses rules. So you got the data here, and so this is our data set. So we got transaction ID, refund, marital status, taxable income, and we got the target variable or the class. So it's simply we are going to build a tree to determine the value of the target variable. So if you are refunded, so the refunded, we got two levels, yes and no. If it's yes, so you got one yes, and this one yes, we got a no. This one is we got a no, and this is what you got a no. So if it's yeah, if we have a newcomer or a new register, new joiner, and the first thing we gotta look into is did he ever get a refund? If it's the answer is yes, then it's not gonna cheat. Okay, if the answer is no, then we are gonna look into its marital status. In marital status, we got single, married, divorced. So if it's married or not married, if it's not married, it's not gonna cheat. If it's married, if it's not married, then we are gonna look into tax income. If the tax income is greater than 80, he's gonna cheat. If the tax income is less than 80, he's not gonna cheat. So that is a decision tree in a nutshell. Of course, there is a lot of math behind the scene, a lot of complication, a lot of information, a lot of methods, which unfortunately is out of the scope of the program. But I will try to explain it as much as possible. So the decision tree, what it does, it simply treats, number one, it calculates, number one, this is what and this is one method. It calculates the entropy of the entire population. The entropy is the chaos, or in Arabic it's called fawda. The entropy is fawda, is the chaos or uncertainty. How uncertain you are if we were to feed, if we have all these features here, how uncertain we are to determine if a client is going to be a 0 or 1. 0 or 1. And to calculate the entropy, there is a function, I believe, if I can remember, it's minus probability of a 0 times log base 2 of probability of 0 minus probability of 1 times log base 2 of 1. That is of probability of 1. I believe this is the entropy, but let me how uncertain. So whatever we get, let's say that we get a value of approximation 0.70. So we are uncertain. If you were to give me this information, I am to determine if if a student will graduate. I'm 70% uncertain that any of these students, 70% uncertain to determine if they'll graduate or they won't graduate. So we simply calculate the uncertainty of the entire 80%. That is step number 1. This is step 1. Okay, step two is we are going to calculate the entropy for every single student. I'm sorry, for every feature. Age. So step number two, we are going to split. We are going to split on age. We are going to split on marital status. We are going to split on education level. We are going to split on hours spent. Okay. So when we split, so this is age. This is marital status. This is experience level. This is our span. So we got names. We don't need to keep the names. If you were to use the prior knowledge, the names is not going to add any value to our analysis. So we are going to eliminate the age from the model. So let's say we are going to split on age. So to split, we are going to look for the mean. We are going to look for the mean. So in our case here, we got 34 plus 40 plus 19 plus 70 divided by 4. So we are going to split on 40. Greater than 40, less than 40. How many records do we have greater than 40? We got 2, right? How many records? Yes, sir.
Greater than 40 is only 170, right?
No, we got 40, and so greater. Yeah, we are gonna. Yeah, please do that. We got only one. 70. And how many records that we have on the less than 40? You tell me, please.
3.
3.
Okay, for how many zeros do we have in the 3? How many zeros and how many ones? So we got 1 0, second 0, we got 2 zeros. And how many ones? We got 1. Okay, for the 70, how many zeros do we have? We got 0 zeros, and we got 1 1. 0 zeros, and we got 1 1. And now we are gonna compute the entropy for both. We are gonna compute the entropy. So the entropy for this one, so we have in total. So we are gonna impute the entropy of the left-hand side and the right-hand side. So in total, we got 4 records. Okay, so in total we got 4 records. So let's calculate the entropy of the left-hand side. The same formula. So the entropy is we got the probability. We got here 2 divided by 3 because we got 2 zeros minus minus the probability of 0, which is 2 by 3, multiplied by the log base 2 of 2 by 3, and now minus 1 by 3 multiplied by log base log 2 of 1 of 3. So this is this part. Okay, and now we are going to multiply it I think it's multiplication, or I think it's addition. Plus, let's assume I think it's addition plus the entropy of the right hand side. So can anyone tell me what is the entropy of the right hand side, please? Plus what?
0. First is P0, so that is 0 over.
Yeah, just before you determine that, just give me the formula.
You mean like 0 by 1, like that?
0 by 1.
Do minus 0 multiplied by log of 0, log 2 of 0, minus what?
Log of, minus 1.
Minus 1, log
base 2
of 1.
1, yeah.
So this is the entropy of age. And the same thing we are going to split the marital status into either married or not married. We are going to do the same for education level, and the same for hours spent. Okay, so we are going to do we are going to split. The first step number 1, we are going to calculate the entropy of the entire 80%. Step number 2, this is what this decision tree does behind the scene. We don't see it, but it's always good to understand the concept. Step number 2 is we are going to split on all features. If you have 200 features, we are going to see 200 split. And we are going to split if it's a numerical value, we are going to split in the mean. If it's a numerical value, if categorical value, in our case we got D, D, M, M, we are going to split on the mode. So we are going to split on either divorced or non-divorced. Okay. Education level, we are going to split on the mean. Hours spent, we are going to split on the mean also. And we are going to calculate for every split of every feature that we split, we are going to calculate its right hand side plus the left hand side and right hand side entropy. Step number 3, please pay attention, this is very important. Step number 3, we are going to subtract the original entropy. We are going to subtract the entropy from step 1 of the entropy of step 1 So we are going to subtract entropy from step 1 and step 1 from all entropies from step 2 one at a time. So in other words, we are gonna take the entropy step 1 entropy minus entropy of age. Step 1 entropy minus entropy of marital status. Step 1 entropy minus entropy of experience level, etc. And let's say that the entropy of the first one is minus 5. The entropy of the second one is minus 6. Is 0.6. The entropy of the third one is minus 6, is 0.6, etc. So we are going to keep only the entropy with the lowest value. In our case, is the age. Age is, we are going to keep the entropy of the age. We are going to keep this split. So we are going to keep the age as a split. Okay. So we got age here. We got greater than 40. We got less than 40. And we got 3 here. And we got 1 here. And we got 2 of zeros. And we got 1 of 1. And we got here 0 of zeros. And we got 1 of 1. So the first step is calculate the entire entropy of the 80%. The second step is we are going to treat every single feature with equal importance. So we are going to split on age, on x1, x2, x3, x4, xn, and we are going to calculate their entropies. Step 3, we are going to subtract the excess entropies from the original or the entire population entropy, and we are going to keep only one split. We are going to keep only one X that has the lowest uncertainty, the lowest entropy. So let's say that we got the original is 0.7, and then after we subtract it from the first entropy, we got 0.5. Then we subtract from the entropy of Martin status, we get 0.6. From education level 0.6, from ours is 0.6. So we are going to keep 0.5 as the best splitter. Okay. Step number 4. We are going to repeat the process for the.
Sorry, in the lowest range, if there is 2 values, so we can take anyone.
Say again.
If in the lowest range, if there are 2 values are same, so we can take anyone then?
Anyone, it doesn't matter, anyone.
Mm-hmm. Mm-hmm. Okay.
Okay. So at this point of time, any question, concern about the step 1 and 2 and 3? Okay. So now we split an A.
Is this documented somewhere?
No, but we are gonna have the recording, and of course we have the presentation, but it's not documented in the presentation.
Oh, okay, thank you.
Yeah. So now we split an age, and we are done with age. So the second things we gotta do is we are gonna split the right hand side of age. Left hand side of age. And the right hand side of age using, we are going to split the right hand side. We are going to split on age again. We are going to split on marital status again. We are going to split on education level and spent hours. And we are going to do the same for the right hand side. We are going to split on age again, marital status, education level, and hours spent. And of course, we are going to calculate, we are going to subtract the entropy of left-hand side from the entropy of age, left-hand side from entropy of MS, left-hand side of entropy of education level, left-hand side of entropy of hours spent, and the same for right-hand side. And of course, we are going to keep only one split for the right hand side. Let's assume that after we did that, we find out the best splitter for the left hand side of age is marital status. So we got marital status, and now we got divorced, married. Okay, and we did the same for left hand side. Let's say for the left hand side, we got hours spent. And we keep the process again and again and again until we create something that looks like a tree. So if so now we are going to get so now after we learn a tree, let's say that marital status and marital status we split again in age, and marital status we got here we got 3. Let's say that we got 2 of them, they are married, 1 of them is divorced, and this divorce here we got the 1, and the 2 we got the zeros. I think we stop here. Okay, so we stop. We have some criterion to stop. So now let's assume that we want to predict Jasmine. How old is Jasmine? You tell me.
Less than 40.
Okay, so
less than 40.
Which direction we are going to go?
Left.
So we got to left. So is Jasmine married or divorced?
Married, left. Yeah.
Then what is her prediction?
20?
No, it's a 0.
That's 0, yeah.
Yeah. So we got a 0 for her, for him or for her. And the Fahd is 45. Is going is 45. So it's a 1. Fahd is a 1. Amin is 37. Is going to be a 0. 37 married. Brahim is 39. Is going to be a 1. So that is how decision tree works. We simply create a list of rules. If age is this, and if x1 is this and x2 is this, then do this. If x, so it's simply creating a list of rules. But this is how decision tree works behind the scene. If you are using entropy, it simply creates the entropy, calculates the entropy of the entire partition, in our case the entire 80%. Okay, that is number 1. Number 2, it splits on every single features possible, excluding the target variable. So this is not, we don't split on graduated because it's a target variable. We split on age, marital status, experiential level, and our spend. And once we split, then we are going to calculate the entropy for every split. Once we calculate the entropy for every split, we are going to subtract those entropies from the original entropy. And we are going to keep only the split with the lowest entropy. The closer the entropy you got to 0, the better. So we are going to keep only one split with the lowest entropy. And that one split is going to be our main split. So in our case, age is the best splitter because it has an entropy of 0.5. And now we are going to split on age. And once we split on age, then we are going to repeat the process, step number 2, on the left-hand side of age and the right-hand side of age. And we keep splitting the right-hand side, left-hand side until we get, until there is a, until we got a pure, until we have only one class. So now we have one class, it's pure, it's called purity. And so the certainty here is, uncertainty is 0%. I'm 0% uncertain. Okay, means I'm 100% sure. So we stop when we reach one class, or we reach the purity of a class of a split. We stop when there is no more data. So that is what we are going to do. Unfortunately, because of we are running out of time, we are going to stop here, and let me give you 2 more minutes to see if you guys have any question, any concern for the foundation, or the mathematical foundation of the decision tree before I dismiss you. And next week we are going to implement decision tree, and whatever is not clear today, of course, it will be cleared out by an example. So questions, concerns?
Sorry, Brother Mo, doing all this decision tree calculation, after that, does they compare the result? Really, it gave the 0 and 1, right?
What is your question again?
Sorry, my question is, after this all like entropy calculation, once we have 0 and 1, like for the new member, like a Jasmine and this one, so that like close to the real, that 0 and 1, like how they know that what we got from entropy, it is exactly should be like that. Jasmine should be 0.
So we
it is just
we just
I mean, my point is, because here we are in the decision tree, in this algorithm, we like what we are doing in overall, we have a 0 probability and 1, and then we go sub function. So doing all these calculations, at the end, we gave Jasmine 0 because of this calculations. My point is, does Jasmine really need 0?
Yeah, Akhtar.
If they compare anywhere, they compare this or no comparison after that?
Yeah, just hold on. So we just built a decision tree on 80%, right?
Yeah.
And we are going to test that decision tree on the 20%.
Okay.
And the 20%, we already know. So for the 20%, we are going to hide the target variable, put it aside. Okay, so once we build the decision tree, then we are going to do fit your 80%, okay, to learn a pattern. And once we fit, then we are going to predict your 20%. And in the fit, we are giving the x and the y, and for the predict, we are only giving x. And this predict, what it does, it will create a column, a new column. It's called predicted target variable. Predicted target variable, and of course, this predicted target variable will have a value of zeros and ones. Let's say it has 0, 1, and 1. And now we are going to compare this prediction with the actual target variable. So the first one is 0 and 0. We got it, great. The second one, 1 and 0, there is a problem in there. The third one, 1 and 1, is great. So the model did one mistake. So that is one mistake. So the model, of course, that we trained at 80% is not 100% accurate. Always there is going to be a percentage of there is going to be a percentage of uncertainty. So if you are happy, let's say the model almost did 90%. He got 90%, 90 cases correct, not one case incorrect. So it could be 95%. Let's say that 95%. So this model here is 95% accurate. So now we are going to apply this model on Jasmine, Fahd, Amin, and Ibrahim. So Jasmine is 0%, is 0. So this 0 means we are 95% sure or sure that it's a 0. Of course, there is a 5% of possibility of it's going to be a 1. And for Ibrahim, we got 95% sure or accurate that it's a 1. But of course, we have 5% of a 0. Always going to be a chance of the opposite. We got 95% for Amin is 0. 95% of Ibrahim is 1. So we started. What was the probability? We started from 58% to 95%. So if we were to guess Jasmine, 95%, 58% is 0. And now when we use the decision tree, is 95% is 95% 0 and 5% 1. So for Jasmine, we start with 58% is a 0, 42% is a 1. For now with the machine learning, is 95% 1 and 5% 95% 0 and 5% 1. Which one is better? Machine learning or the guessing?
ML, yeah.
Machine learning is better. We have more accuracy in here. But before we train the model on new students, we have to test it on the students that we already have a target variable and compare the actual target variable with predict target variable. Whatever percentage, if we are happy with it, then we are done. Otherwise, we need to go back and probably acquire more data, change the partition. I mean, please mute yourself. I mean, there is a lot of echo coming from your side, sir. Please mute yourself. Thank you. So if we are happy with the percentage after we test, then we proceed to the new data set, unknown data set. Otherwise, we might need to tweak a little bit our model to improve its quality. That is what we are going to learn next week. Okay, Ali?
Thank you, Brother Mo. Yeah, no, it is clear. Thank you so much. Yeah,
welcome.
One question. What is the minimum accepted accuracy percentage?
Is anything that beats your anything? Please mute yourself. I mean, once you ask question, please mute yourself. There's a lot of echo. It's anything that beats your guessing. That is the minimum. Of course, we are not going to get. If you were to create a model that is 60%, I don't think that is a good model. 58 and 60% is too close. 70, I think we can live with it. 70 plus something that we can live with. That is the minimum I can live with. And the minimum depends on the business. The business say no. We want a model that at least predict 95%. I don't know. We are not going to live with 60%, 70%, 80%. But in general, a better model that its accuracy is too far from the guessing accuracy, from the guessing values. Okay, Amin?
Yep. Thanks, Mo.
Yeah, welcome. And probably next week is going to be our last week of the program. And now we promised 10 weeks, but it's simply we are going to complete the program next week. So we are going to have one more week, and we should be done with the program. At least with this program, you are going to have a basic knowledge of how to, how this machine learning works. How to implement a very simple machine learning algorithm, and it should be your jump start to start looking and educating yourself, training yourself on data science, which is the future. So I'll see you guys next week. Until then, you guys have a great weekend, and bye everybody. Assalamu alaikum wa rahmatullah.
Assalamu alaikum, Brother Mo. Thank you so much.
You're welcome.
Thanks, Brian.
Thank you.
You're welcome.